Welcome to the session for second class of programming, where we will be learning about numerical bases. So we will be learning about decimal, octal, hexadecimal, binary. Those are the ones used in programming. But before we proceed, don't forget to like this video, don't forget to subscribe, because this helps a lot of the channel to bring more stuff for you. So let's get it started. The whole thing in your life, you have been teaching to count to the decimal numbers. The decimal count, you might be thinking, oh, it's decimal count, it's composed of 1 to 10. No, it's wrong. Your whole life is a lie. It's not about 1 to 10. But pay attention, it's about having 10 symbols, which goes for 0 to 9. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, composing 10 symbols. And why is it so important that we learn this now? Because you will learn the rule that you have used automatic your whole life up to this moment. Now let's learn how exactly does it works. When we get here to the number 9, which is the last number here on decimal, we go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How I'm going to say the next number? The next number is actually a repetition. So we do a repetition for the first number that has a value. So 1 means that we have one unity, so it's the second number, plus the first number that is 0, the new number. So remember this rule. The first number which has a unity value, it's our second digit, and the first number that means 0. This rule will go for every other count method that we are going to use in the computing. So take a look here. We have 9, and we want to have the next symbol is going to be 1. The first number that holds a value plus 0. Now we have 10. That's very interesting, right? Now let's go for the octal base. Although it's a octal which comes from 8, it doesn't have the number 8. It goes from 0, 1, 2, 3, 4, 5, 6, 7, and it stops at 7, but we still have here 8 numbers, 8 symbols. A symbol is not always a number. That's very important for you to know, because we're going to go for that on the hexadecimal. So here, when we want to say the number 8, we're going again on the same rule that you just learned. Get the first number with value with 1 and the new number with 0, and we have them inverted, so we have number 10. So in octal base, the number 10 actually means the number 8, as the number 11 going to be the number 9. So let's go for the hexadecimal now, that change things a little bit. The hexadecimal, which comes from 16, it has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops! We don't have the number 10, because 10 isn't a number. As we have learned, 10 is a repetition. 10 is a repetition of the 1 and 0. So here we don't have the number 10 in hexadecimal. So what's going to happen here? We have A, B, C, D, E, F. That's the big difference between the hexadecimal and the decimal count. We have more symbols. We don't stop at 9 and start repetition, because 10 is a repetition. So we have A representing 10, B representing 11, C representing 12, D representing 13, E representing 14, and F representing 15. So interesting, right? And hexadecimal is the way that your memory address the values, the variables that you have stored. So your memory is organized in hexadecimal addresses that your processor will pull up to follow the value that you're looking for, but we will see that in our next class, number 3. Alright, So how we're going to spell number 16, because F's number 15, how we're going to expound the number 16 on hexadecimal? That's pretty simple. We go back to a rule that we get the first number with a value, which is 1, and we get the first number, the whole thing, it's 0, the new number, and we have the number 10. But it's crazy because 10 now isn't 10. It goes for number 16. So that's very important for you to remember. It goes for the number 16. Oops, yeah, 16. Okay, so now we go for the most important one, the magical number. What's binary? Binary is how the whole system works. This whole video that you're watching, it's whole and binary. Your whole computer, your navigator, everything you do on Windows is made out of two numbers, a combination of two magical numbers. And these numbers are 0 and 1. It's important to know though that the combination of those numbers isn't really is a symbology. It's not really numbers. We use numbers so we humans can understand, but it's different the way that the computer understands. But we see that on the next class. Alright, so let's go for the binary here. We have two numbers as I have made a circle on it on every single base. So you understand what's going to change here, and it's going to be pretty easy to learn. So, on binary we have two numbers with 0 and 1, two symbols, okay? So 0 means 0, yeah, so 0 is our new number, and 1 gonna means 1. So far, so easy, right? But then how we're going to spell 11? We go back to the rule that I teach you in the beginning when you're counting up to 10. Here we go back. So when we want to say 10 here, we pick the first number that has a value and the number that has no value. Means 2 in binary gonna be the combination of 1 and 0 because we have the repetition. So we have the number 10. So 10 is equal to the number 2. So easy, right? Let's go for the number 3. 3 is the repetition of the next number that 0 can assume in here. As we only have two numbers to repeat, we are at 0, we're going to 1. So we remove 0 and add 1. Now we have the number 11 or 1, 1. And the number 11 is going to mean 3. Yes, guys. So here where it might be hard for you at the beginning, but it's pretty simple. Number 4. The number 4 is going to be composed by the repetition as we do in decimals. When we go for the number 99, the next repetition is the first number that has value plus 2 zeros. So we have 2 zeros and then we have the number 100. And the same thing is going to happen here. We're going to add 2 units of 0 at the first number that has unity value. So we have 100. 100 in binary is going to be the number 4. So now we're going for the number 5. To get to number 5, we get the number and the next repetition here on the last unity, like we do on any other of those, is going to be 1. After 0, it is 1. So we have 101, and 101 means 5. And the next number, even easier. We move this unity here to here because of repetition here. So 0, the next number is 1, so it's 1, 1, and the next number after 1 on the repetition, we have here 1. Oh, where do we go? Woo! 0. So we have the number 110, that means 6. On 7, we have the next number after 0, 1. 111 goes for 7. And then we go for number 8, which is going for 1,000. Again, we go to the same rule here, adding one more unity of repetition. So we have 1,000 which means 8. And now here we have 1001. That means 9. And go for 1010, adding unity here, repetition here, number 10, and binary, which goes for 1010. That's so easy, guys, and you must learn it. So your next class, which will be the number 4, will be talking about binary operations, how the computer works. So thank you guys so much for watching. Don't forget to like if you didn't do it yet. Don't forget to subscribe, because you get more classes and you'll be learning how to make softwares and how to make games, which will be the key feature of all these classes. So I'm preparing you from the ground to the ultimate learning that we have to craft, to make our games. So thanks so much for watching. Like it, subscribe, and see you guys in the next class. Bye bye.